Okay, this is more of an extension of deciding if lines are parallel. You might actually have to justify or to prove that two lines are parallel, okay? And to do that, you're going to use one of the converse theorems. So I did show you those theorems. If I can find that paper again. Okay, we had our theorems that said if lines are parallel, then certain angles were congruent or supplementary. And then we talked about the fact that the converse of all of these were also true. So if we know a relationship, an angle relationship, like corresponding angles being congruent, then the lines are going to be parallel. Okay, this first one, the corresponding angles, that's actually a postulate. The rest of them are theorems. Alright, but we're going to use these to actually justify or prove. So before I just asked you which lines are parallel, now you have to give a little more. You've got to tell me why. So we can go about this a couple ways. One would just be to go ahead and give the theorem. So I'm going to show you some examples here. Alright, given this picture here, if I knew any of the corresponding angles, if I knew any of those angles were congruent, that would be enough by the converse theorem to show that the lines would be parallel. So if I wanted to prove these two lines parallel, I could show you that either, we're looking at the corresponding angles right now, so either angle 1 and 5 were congruent, um, 2 and 6, three and 7, or 4 and 8. So if I was trying to show you that these lines were parallel by any of these congruencies, I would be using the converse of the corresponding angles postulate. That's what I would be using. Okay, the next example here, or the next theorem, converse theorem I want to talk about is if we were talking about alternate interior angles. Okay, so if I show you that alternate interior angles, so for example 3 and 6, if I show you that angle 3 is congruent to angle 6, or angle 4 was congruent to angle 5, I would be justifying or proving that these lines were parallel by the converse of the alternate interior angles theorem. What I want you to notice right now is that, before I didn't give you the names of the theorems because I just wanted you to see that they existed, but now hopefully that you've gotten more comfortable with the vocabulary, I just want you to notice that the reasoning or the justification of these lines being parallel is just whatever the vocabulary word is of the angles, the relationship of those angles that you're looking at. So for example, here's the next one. If I wanted to use the alternate exterior angles theorem, the converse of it, I would just be looking at alternate exterior angles, and this time they wouldn't be, oh no, they would be, sorry, I was thinking the next one. Okay, alternate exterior angles would be like angle 1 and 8, and they would we're still talking about congruence here. Angle 1 is congruent to angle 8, or angle 2 is congruent to angle 7. Okay, so if I knew that either pair of those alternate exterior angles were congruent, that would be enough to justify by the converse of the alternate exterior angle theorem that the lines are parallel. Okay, and then the last one I have here is the consecutive interior angles. Again, I don't know why no books ever talk about consecutive exterior angles. It seems to me like there's no reason why we couldn't talk about those, but I just put this one because this is the one you find in the books. Consecutive interior angles, so that would be like 3 and 5. And this time we wouldn't be looking at them being congruent, we would look at them being supplementary. So consecutive interior, like angle 3 and angle 5, the measurement of angle 3 plus the measurement of angle 5, if that sum was 180, then I would know the lines are parallel by the converse of the consecutive interior angles theorem. Or if I knew that angle 4 and 6 were supplementary, so if I knew that the measurement of angle 4 plus the measurement of angle 6 was 180, that would also be enough to say that yes, these lines must be parallel by the converse of the consecutive interior angles theorem. Okay, what I want you to notice, this is very, very important, super, super important, is what I am not talking about here are vertical angles and linear pairs. Okay, we talked about this in the last standard. Those are the same intersection. Okay, so for example, the one you can see right now is if I told you that angle 5 was congruent to angle 8, well, that's only referring to line B here. It doesn't have anything to do with that other line. In fact, I can't even see it. And I can tell you right now that 5 and 8 would have to be congruent. That does not prove lines are parallel. Same with angle 7 and 8 adding up to 180. Okay, yeah, that's true, but that's not going to prove anything about the relationship between that line up there that we can't even see. Okay? Alright, I want to show you a little bit about two-column proof, okay? This is something that we're going to do a lot more when we look at the triangle theorems, congruent triangles, but I'm just giving you a little introduction right now. This is included in this standard. If I want to justify lines are parallel, I might write a two-column proof to do that. So, for example here, what I did is a two-column proof is you've got a column of statements, and then you've got your reasons or justifications for those statements being true. Your first statement is often one that's given, okay, and then the reason I would actually say given, okay, that's how I knew that. How did I know that? Because it was given to me. Your last statement is always whatever they want you to prove, okay. Now I can't say that reason yet because I'm going to have to go through these. Okay, so angle 1 is congruent to angle 8. I knew that because they gave that to me, so I wrote given for that reason. Angle 8 is congruent to angle 5. Angle 8 is congruent to angle 5. Okay, that's true by the vertical angle, actually I think it's angles theorem. Okay, and you might not have heard me say before, like call this an actual theorem, but when we're justifying, we're using postulates and theorems. Alright, but notice, if you know the vocab word, you should be able to say what the reason is. Okay, 1 and 5. This one is okay, so I was jumping ahead of myself. If angle 1 is congruent to angle 5, I can't say that, I'm not getting to parallel lines yet, okay? This isn't quite the corresponding angles theorem yet. What this is see how the first is equal to the second, and the second is equal to the third? Okay? That means the first and third are equal. And that's true by the transitive property. Okay, so I was tempted actually right here to say corresponding angles because that's what they are, but that's not, just because they're corresponding doesn't mean they're congruent. Now that I've said that yes, those corresponding angles are congruent by that transitive property, okay, the first is equal to second, second's equal to third, I now know that 1 and 5 are equal to the first thing and that third thing were equal by the transitive property. And now that I know that, now I can say, okay, well, if I know that corresponding angles are congruent, then the lines have to be parallel. So that's true by the corresponding angles converse. Okay?